Hi, I want to introduce the internal assessment for science. This should just be an introduction to get you started. There will be more details and discussion in class, but please make sure you remember or write down any questions that you have. So, the task, the internal assessment, you have one in all of your IB courses. The one for all of your science is a science investigation. So, the requirements for science are that it is 10 hours total, which includes prep time, data collection time, and writing time. Typically, it takes more than 10 hours, especially if it doesn't all go smoothly right away. 6 to 12 pages long, so minimum is 6. The maximum is 12. They might not read it after 12, so it's important that you keep it in that range. It needs to be complex, like this shouldn't be something a middle school student should do. It should be more complex in that there's some sort of analysis and it's not an obvious kind of answer to your research question or something I could quickly Google. It's a little bit more than that. So you need to have a purposeful research question. Your research question should include your variables. Like how does this independent variable affect the dependent variable? And then through kind of what process. You are doing this individually, so everyone does their own. Everyone comes up with their own investigation, their own variables. I cannot tell you what to do. I cannot give you a list to choose from. You have to come up with that on your own, but I will guide you and help you along the way. All right, so this is scored or graded. They call it assessment. It's scored internally. So internal assessment means that I, as your teacher, will score this. Externally means that IB will then grade my grading. So I assess it and give you a score out of 24. IB then will look at all of yours, and if my scoring's good, they'll keep the score. If I'm too hard on you, which rarely happens, they might raise the score. If I'm too easy on you, they will lower the scores. So this score out of 24 comes in five different parts, which I'll go through in more detail later, but personal engagement is 2, exploration, analysis, evaluation are all 6, and communication is 4. So then overall, this is 20% of your final IB score. You'll get a final IB score in July. 20% of your chemistry score is from your score on this. The other 80% are the tests, the external assessment, the tests that we take in May. All right, so there are 3 different methods to do this. The first is a hands-on investigation. This is like what you think of as a traditional experiment. You collect your own data, you plan your procedure. You don't know the answer, but you're investigating it. These can be done in the classroom, in my lab, or they can also be done at home, depending on time and materials and all that. And there is a sheet for guidance, which I'll show you in a minute. Let me go through the other methods first. So method 2 would be some sort of computer simulation. Here's where you aren't performing the experiment, maybe because it's too complicated or you don't have the materials, but a simulation could do this for you. For the simulation, it's a computer, right, model of an experiment. You could also do kind of a combination of methods 1 and 2, where you look at a computer simulation and a hands-on one that you've done and compare them. The third possible method is a database investigation. This is where you're not completing it at all, whether it's a simulation or in person. Someone else has completed an experiment and you're looking at the data from theirs and you're looking at it in a different way. Possibly you're looking at databases or 2 different data sets from different experiments or different times or something they didn't compare in their experiment. And then graphing or modeling it somehow in a different way. So let me show you a little bit more about these. So the experimental or the hands-on, this is the linked document in there. Your variables need to be quantitative, so don't do brand comparisons like, how much better is aspirin than like brand name aspirin with generic aspirin. That's a brand comparison, okay? Quantitative, numeric. Bare minimum 5 data sets. Otherwise, you can't determine a trend at all. But if you have more time, do more. I should see no bar graphs, line plots, scatter plots. It's easier if you're interested in this topic. Be creative. Don't just Google, your procedure, you're going to lose points on personal engagement. You need to come up with it yourself. So you can do your own, or you can Google it, you can find a procedure, but then you manipulate it to fit exactly what you're doing. That's the personal engagement that you can show. I have some ideas here. This is not a list to choose from. This is hopefully to spark interest, like, oh, that's interesting. Oh, I could do this. And then an example of an IA done and its score. The simulation one, same kind of information here. You're looking at a wide range of independent variables. You can have multiple or different dependent variables, so you can actually access kind of more possibilities. Choose an open-ended simulation, so there's not going to be just like one set answer. Avoids non-numeric ones, so right, we still want that quantitative. And then resources, I've got a few sites here listed that might give you some help, some ideas to get you started on like possible simulations, along with just some examples. Please don't do any of these, but just some examples to get you thinking like, how could I do these? And an example of one that a student's done and how it was scored. The database, here we go. The best is to use multiple databases, compare different data sets. You can read through all that, but your resources, I've got a couple places where you can find data. Sometimes that's the hardest part with these, is actually finding data that you're looking for. Some example ideas and a student example with scoring. Okay. So 3 possibilities. Every single one of them must contain a clear, focused research question. So there should be clearly independent and dependent variables like I talked about before. Quantitative. So numeric, independent, numeric, dependent. Okay, how does this relate to that? And they should be numerically. You could get an equation, you can look at averages, we can maybe calculate something else in our analysis. You will have a background. So the background is the research that you're going to do. It will be cited just like you would in English or a history paper. The background is that part of this, where you are going to have your sources, you're going to cite it, and you're going to tell me and whoever else is going to read this all the information that we need to know to understand what you did and what you've learned. Data, primary or secondary, either you're doing it or you found it somewhere else. So all of your data laid out nicely, neatly organized, your analysis of your data, what your conclusion is, and your conclusion should relate back to answering your research question. And it should circle back to your background. What from your background helped you kind of determine what your conclusion meant. Evaluating your procedure, whether you came up with it yourself or someone else did, or evaluating their procedure, kind of what was the error, the limitation, how did it affect your data, and what could you have done to improve it? A works cited, and there is no hypothesis needed. Could you have one? For sure, but do you need one? Not at all. Okay. All right. Kind of a comparison or discussion between doing a hands-on experimental versus the other two, the simulation or the database. Generally, it's easier to do a lot of those parts I was just talking about if you are doing an experimental one. It's easier to demonstrate consideration for factors that influence because you are coming up with the procedure. It's easier to show how you're taking into consideration the uncertainty and proper equipment and things because you're doing it, and possible sources of error because, again, you're doing it. You can still do all this through the simulation database modeling ones. The bonus for them is that it can be less time to do your experiment, collect your data. You can get typically a much wider data set that you can collect a lot more data because you don't have certain lab times where you can complete it. All right, concerns with the simulation and databases. There isn't much uncertainty to them, and that is a piece to discuss. And it can be difficult to make them complex enough. It's possible. It's just maybe that's the part that's more challenging. All right, so here's how you're getting scored. I referred to this, your personal engagement. This is showing that you are involved. It doesn't mean like, oh, I've always wanted to know about this topic since I was a little kid. They don't care about that. They want to know that you went through the effort to make your procedure or modify it, that you contributed to the design, that you were creative. So that is worth 2 points. Exploration, this I like to think about as like your background, your procedure, kind of, were you able to collect the right data? Did you take into account controls and other variables? Did you address safety issues? Do you have the right methodology, right? That's your procedure. Do you have a good focused research question? So all kind of that pre-lab type stuff that we talk about. Analysis, this is where you're showing what your data means. So proper analysis of your data, this should be typically mathematical calculations. Hopefully this is going to show a graph, a nice scatter plot. Maybe we're going to have some sort of relationship or an equation. We're looking for appropriate and justified analysis. The evaluation then is going to be your conclusion and evaluation. They just call it evaluation. So what does your data set mean? Bringing it back to your sources, like do your sources support this based on your background? And did you evaluate your methods? Like I talked about before, right? An impact of your limitations and suggested modifications. All right, the last piece is communication. Communication is like basically, could we read it really well? Was it clear and easy to understand? Did you have the right labels, right terminology? Were your graphs appropriate? Things like that. It doesn't specifically say grammar or anything like that, but it's implied. So this would be where you'd lose if you went over the 12 pages or under the 6 pages. If you didn't cite your sources, things like that. If you went on and on about something that wasn't relevant, that would all be a part of this. In terms of points, your personal engagement communication, you should be able to get all of those points 2 and 4 fairly, I don't want to say easily, but they're very, very doable. The other ones, which is why they're more points, are more challenging. That's really kind of the meat of it all. All right, so some helpful hints. Be aware of the criteria, and we're going to go through them in more detail, but marks are given by how well your work matches the descriptors. So you want to make sure you're matching those descriptors and keep checking them, keep referring back to them. And every time I check in with you, I will be referring to them. Seek and follow feedback, like ask for help. We'll do peer reviews. You will meet with me multiple times to sit down and go through like your plan before you start, like while you're doing it. I'll give you a lot of feedback on your quote unquote rough draft because I want it to be as final as you can make it. All right, and be enthusiastic. You're in charge. This is where you get to decide what you want to do. You get to be creative. You get to have fun. You get to finally be like, oh, this is interesting. I want to learn more about this. This is where you get to do that. Okay. So where to start? So first we need to determine a topic and we'll kind of brainstorm and talk about some stuff. But as you're going through and reading all these kind of things and kind of figuring out, like those documents I showed you, start to think like, what's interesting to me? What's a question I want to answer? Determine which method would be the best for your work. So don't choose your method and then your topic, choose your topic and then your method. Okay. And then use that resources doc for whichever method to help you. All right, so we'll talk about a timeline in class and kind of give you a calendar and all that. Please write down any questions that you have and please make sure you ask them.